Hi, I'm Mark Barsamian. In this video, I'll be discussing increasing and decreasing intervals for a function given by a formula. Now recall that in the previous video, we discussed increasing and decreasing intervals for a function given by a graph. So this is a new thing, functions given by a formula. Now, this is material from section 4.1 of the book, and as I mentioned in the previous video, I don't think that section 4.1 of the book is organized very well. So it's hard to be more specific about which reading corresponds to this video because it's actually scattered throughout section 4.1. The homework for this video is this collection of 4 exercises from section 4.1. The asterisk on this exercise indicates that that's an exercise that's in the book, but it's not in the MyLab system. So it is not part of your homework H54 in MyLab, but that's an exercise that you should try to do. Now there'll be some important tools that we'll use in this video from section 2.3, which was continuity, the idea of sign charts. Remember the theorem about sign properties on an interval. If a function is continuous on an interval, and if the function is not 0 anywhere on the interval, then the function either remains positive or negative on the whole interval. So in other words, a function can only change sign from positive to negative or negative to positive at an x value where the function is either discontinuous or where the function has an x-intercept, that is, a place where the y value is 0. Now that's the idea behind the definition of what's called a partition number. Remember that a partition number for a function is a real number x such that either f is discontinuous at x or f of x is equal to 0. So the idea is that the partition numbers for a function, f of x, are the only places where the function can change sign. And in section 2.3, we built sign charts to help us organize our analysis of a function to determine the sign behavior of the function, where the function is positive or negative or 0. So we'll just do 2 examples today. They have different functions, but they have the same tasks. In example 1, we're considering this 3rd degree polynomial. In example 2, we're considering this 4th degree polynomial. And in both of the examples, we'll do questions A, B, and C. In question A, we'll find the intervals on which f of x is positive or negative. And in question B, we'll find the intervals on which f of x is increasing or decreasing. And then question C, we'll sketch a graph labeling all the important features that we've learned in parts A and B. I'll point out that your homework exercises are just about B and C, finding the intervals where f is increasing or decreasing. I want to add this part A about where the function is positive or negative to make it clear the distinction between a function being increasing and decreasing and being positive or negative. We discussed that in the previous video when we were discussing functions given by graphs. Okay, so let's start. Example 1, f of x is this cubic polynomial. Find the intervals on which f of x is positive or negative. Well, let's outline our strategy. Remember what we discussed earlier. The only places where a function can change sign are the partition numbers, the x coordinates that are partition numbers. So you analyze the sign behavior of a function by finding the partition numbers and making a sign chart for the function. So our strategy should be find the partition numbers for f of x, make a sign chart for f of x, and then use that to answer the question. Now, let's start with partition numbers. Remember the definition of partition number. Partition number is an x value that causes f to be discontinuous or causes f of x to be 0. Well, notice that our function is a polynomial. So polynomials are always continuous. So there are no bad x values. There are no x values that will cause f of x to be discontinuous. So since there are no bad x values, there are no x values where f of x is discontinuous, the only partition numbers are going to be the x coordinates that cause f of x to be 0. So we have to set up this equation and solve for x. So I'm going to turn that equation around. Now it turns out that this equation, this function, can be factored in the following way. Now, how do we get that factorization? Well, that's a subject for a prerequisite course. I will point out that anytime you have a factorization, it's worth checking. And you check factorization by simply multiplying out all the terms. And again, I won't do that calculation here because that's prerequisite material, but that is needed in order to do these problems in calculus. So there's our equation, 0 equals f of x, with f of x in the factored form. And you can see that the solutions to this equation are x equals minus 1 and x equals 5. So those are the only solutions to that equation, so those are our partition numbers. All right, so we've made our partition, we found our partition numbers. So the next job is to make a sign chart for f of x. Now let's remember how to do that. We find the partition numbers. Okay, we've done that. Now we have to put the partition numbers on a number line. And remember that my technique for this is to put the partition numbers on the number line and add on to the number line the information about what happens on the graph of f of x at those points. So there's the start of our sign chart. So again, my version of sign charts includes this. You put down at the partition numbers exactly what happens at those partition numbers. That's important, and it's easy information because we found the partition numbers by looking for certain kinds of behavior. So we might as well put that behavior on the sign chart. Also, my version of sign charts includes a title. You're going to see why that's so important today, because we're actually going to have more than one sign chart for more than one function going on. So it's important to keep them straight. Now let's go back up and look at our instructions for sign charts. The next thing we're supposed to do is select test numbers and determine the sign of f of x at those test numbers. So there are my test numbers. So we have to substitute those test numbers into the formula for f of x and figure out whether f of x is positive or negative. Well, I'm going to use the factored form of f of x because I'm substituting in particular x values, and I've mentioned throughout the course that when you're substituting in particular x values into a function, it's most convenient to use the factored form. So f of negative 2 is positive. We don't care about the value, we just want to know about the sign. So f of 0 is also positive. So f of 6 is negative. So these results tell us not just about the sign of f at these test numbers, but actually on the whole intervals. So f is positive and negative on those whole intervals. Now in the book they use a different kind of notation for this. They do this. They put a bunch of plus signs across the whole interval. Same idea. I just like making those brackets. It's a little bit faster. So there's our sign chart. Our final part of our strategy was to use the sign chart to answer the question. The question was, what are the intervals on which f of x is positive or negative? Well, let's answer that on the next page. So our conclusion is f of x is positive on those intervals. Now notice this symbol looks like it could be a point. It looks like it could be an xy pair, but it's not. It's an interval. Those are both x coordinates in that symbol. This symbol clearly could not be a point. The symbol negative infinity could not be an x coordinate, so that one is pretty unambiguous. But when you see a symbol like this, a pair of numbers separated by a comma in parentheses, you have to pay attention and keep in mind whether that symbol is meant to be interpreted as a point or as an interval. In this problem, we're meaning for that symbol to be interpreted as an interval. Now we have to answer the question, where is f negative? And that's the answer to question A. Question A was to find the intervals where f of x is positive and the intervals where f of x is negative. Let's go on to question B. Question B is to find the intervals on which f of x is increasing or decreasing. Well, remember that we have a correspondence. From the previous video, so we have this correspondence that if f prime is positive on an interval a comma b, then that tells us that f of x is increasing on the interval. And similarly, if f prime is negative on the whole interval, then f of x is decreasing. So our strategy should be to find f prime of x, determine the sign behavior of f prime of x, and use that to tell us about the increasing, decreasing behavior of f of x. So our strategy should be find f prime of x, determine the sign behavior of f prime of x using a sign chart, and then use the sign chart for f prime of x to make conclusions about the increasing, decreasing behavior of f of x. Okay, here we go. Let's get f prime of x. So our derivative is a standard one. It's minus 3x squared plus 6x plus 9. Now we need to determine the sign behavior of f prime using a sign chart, so we need to find the partition numbers for f prime. Now observe that f prime of x is a polynomial, so there are no x values that will cause f prime of x to be discontinuous. So the only partition numbers will be the x values that cause f prime to be 0. So we're going to set f prime of x equal to 0 and solve for x. So when we set f prime of x equal to 0 and solve for x, we end up factoring f prime of x, and you can see that the solutions to this equation are x equals minus 1 and x equals 3. So those are the partition numbers. And it's important to keep straight what they're the partition numbers for. They're the partition numbers for f prime of x. Earlier we had partition numbers for f of x. The partition numbers for f of x were x equals negative 1 and x equals 5. All right, so we've got the partition numbers for f prime of x, so let's make a sign chart for f prime of x. So we start by putting the partition numbers for f prime on a number line and indicating the behavior of f prime at those partition numbers. Again, that's something that they don't do in the book. And also, we title the sign chart. That's very important because remember, we've already got one sign chart. We built a sign chart for f of x up here. So we're making another sign chart. It's important to keep straight what it's the sign chart for. Now we need test numbers. And we determine the sign of f prime at those test numbers. Now for that, we'll use the factored form of f prime. We see that f prime parentheses negative 2 is negative. We don't care about the value, just the sign. F prime parentheses 0 is positive. And f prime parentheses 4 is negative. So let's put that sign information on the sign chart for f prime. And then finally, we have to make our conclusions about the increasing, decreasing behavior of f of x. We'll do that on the next page. So the fact that f prime is negative on that whole interval tells us that f is decreasing on the interval. We want to state that clearly in a sentence. So I state that f is decreasing on these intervals because f prime is negative. It's very important to be able to say why. And notice that it's important to use the actual nouns, f and f prime. It's common for students to say things like, it's decreasing because it's negative. That's actually an incorrect sentence. In that sentence, the word it's refers to some function, and that's incorrect. Here we have, in my sentence, we have two functions. We have one function called f of x, it's decreasing, and we have another function called f prime, it's the thing that's negative. So you can't say simply, it's decreasing because it's negative. That's incorrect use of pronouns. You have to use the actual nouns. F of x is what's decreasing. It's because f prime of x is negative. So there's our conclusion. All right, let's go on. In question C, we're supposed to sketch a graph and label all important features. Well, let's go back up and look at what we've learned about our function. Our function is positive and negative on those intervals, and of course we know that at the endpoints of those intervals there are x-intercepts. So let's start by making a set of axes and put that information about the sign behavior of f of x on those axes. So from question A, we know about the positive and negative behavior. F is positive on these intervals, and F is negative on this interval. Now, based only on that information, we could make a crude sketch of the graph of f of x. So again, we don't know anything else about the function except that it has to be above the axis, and below the axis. But we've only used, so far, the information from question A. In question B, we'll get some information about the increasing, decreasing behavior of f of x, and we'll realize that we can be a lot more precise in our sketch. So let's get rid of this hand-drawn sketch right now, and let's go on and get our information from question B. From question B, we know that f is decreasing on these two intervals and is increasing on that interval. So x equals 3 is an important x value, so let's put a dotted line here. And let's go back up and look at some more information that we have from doing the work for part B. In question B, we found that f prime of x is equal to 0 at -1 and at x equals 3. Well, those are two places where the graph of f of x will have horizontal tangents. So we know that the graph has to have a horizontal tangent at x equals -1 and at x equals 3. Now we don't know how high the graph will be at x equals 3, so let's just do this. The graph has to go through one of those horizontal tangent lines, kind of like Venetian blinds. And then let's add the increasing, decreasing behavior that we've determined from question B. So f was decreasing to the left of x equals -1, and then f is going to have to go through that point, and then f has to be increasing, and then f has to go through one of these horizontal tangents horizontally, and then f has to be decreasing from then on, and f has to go through that point. So here's one possible graph. So there's the sketch of a graph that has all that behavior. Now we could figure out the coordinates of that point where x equals 3 by substituting x equals 3 into the equation for f of x. But we can just leave this here. This is enough for this problem. We're just asked to find the features that we found in questions A and B. That's the end of that example. Let's go on. Example 2 is the same kind of problem and the same questions. Question A, find the intervals on which f is positive or negative. And question B, find the intervals on which f is increasing or decreasing. So we'll have the same strategy for question A. We're going to find the sign chart for f of x and use that to answer the question. Now, of course, f of x is a polynomial, so there are no x values that cause f to be discontinuous. So the only partition numbers are going to be the solutions to the equation f of x equals 0. Now, to solve the equation f of x equals 0, it's helpful to have the factored form of f of x. And from that factored form, we see the solutions are x equals 0 and x equals 4. So those two numbers, x equals 0, x equals 4, are the partition numbers for f of x. So now we make a sign chart for f of x. So there's our number line with our partition numbers put on the number line, and the behavior of f of x at the partition numbers indicated. And there's our title for the sign chart. Now we need our test numbers. And then we find the sign of f at those test numbers using the factored form of f of x. So the result is that f of -1 is negative. Now, notice that I am very careful when I substitute in my x values. I always put them in parentheses. And then I do the calculations, and you have to be careful of things like this. Numbers with negative signs on them being raised to a power. Now let's compute the sign of f at x equals 1. f of 1 is positive, and f of 5 is negative. So let's put that information on the sign chart. And there's our finished sign chart. And then finally, we use our sign chart to answer this question. Now remember, the question was, where is f of x positive or negative? This is a sign chart for f of x. So that's giving us the exact information that we need. So f of x is positive on the interval 0, 4, and f of x is negative on the intervals -infinity to 0 and 4 to infinity. Let's go on. Question B, find the intervals on which f of x is increasing or decreasing. So here the strategy will be find f prime of x, make a sign chart for f prime of x, and use that to answer the questions about the increasing, decreasing behavior of f. All right, so there's our strategy. Let's find f prime of x. So there's our derivative. Now we need to find the partition numbers for f prime of x. F prime of x is a polynomial. So we have to set f prime of x equal to 0 and solve for x. So the factored form is the most useful form for this equation. And we can see from the factored form that the solutions to this equation are x equals 0, x equals 3. And so those are our partition numbers. Now, we make a sign chart for f prime of x, and again, we have to be sure and label it. And be sure and put the information at the partition numbers about what those partition numbers cause. Now we identify test numbers and find the signs of f prime at those test numbers. So there are our sign results. Now notice again the importance of using parentheses when you put in x values. I've got -1 in parentheses squared, and then that's being multiplied by -4. So I square the -1 first. Order of operations says that you do this -1 squared before you multiply by -4. So I have -4 times the number 1. Now let's make our conclusions. Remember, the questions were, where are the intervals where f is increasing or decreasing? So we use the sign chart for f prime to answer those questions. So you see that f of x is increasing on the intervals -∞ to 0 and 0, 3 because f prime is positive. And we see that f of x is decreasing on the interval 3 to infinity because f prime is negative. So again, I want to stress the importance of labeling sign charts. In question A, we had a sign chart for f of x, and it told us about the sign of f of x. It didn't tell us where f of x is increasing or decreasing, it just told us where f of x was positive or negative. We had the sign chart labeled. We were supposed to find out where f of x was positive or negative, and the sign chart told us exactly that. In question B, we had a sign chart that told us about something being positive and negative and 0, but that something was f prime. What we did with that information is we translated that into information about f. The conclusions we drew from this sign chart were that f was increasing and decreasing. So again, the previous sign chart, the conclusions we drew were that f was positive or negative. In part B, the conclusions that we drew were about f being increasing or decreasing. So it's important to label your sign charts, keep track of what they're the sign chart for. All right, let's go on. Question C, sketch the graph and label all important features. All right, well, let's go back up and look at our results from A and B. In question A, we found this sign behavior for f of x. So let's put that information on a number line. The partition numbers were x equals 0 and x equals 4, so those are going to be x-intercepts on the graph of f of x. We found that f was negative to the left of 0, was positive between 0 and 4, and negative to the right of 4. So just on that information alone, we could make a crude sketch at this point. We don't know anything else about the function if we just use the positive negative behavior, so we have no idea if it wiggles, where the wiggles occur, and so on. Well, for that, let's erase this black curve and let's go back and look at the results of question B. Question B gave us this information about increasing, decreasing behavior, and this information about where f prime was 0. So we see that the important x coordinates are x equals 0 and x equals 3 because those are x coordinates where f prime is 0. So those are going to be coordinates where the graph of f of x has a horizontal tangent. So let's put those points on the graph right now. Now, at x equals 0, we know that the graph is going through this point. But when x equals 3, we don't know what point the graph is going to be going through. So we just have to put a dotted line at x equals 3. And some potential horizontal tangent lines along that dotted line. So wherever the graph of f of x is, it's got to be positive at x equals 3, and it's got to have a horizontal tangent at x equals 3. Now let's go back up and look again at our results from B. So we see that f is increasing on those two intervals from negative infinity to 0 and 0 to 3, and f is decreasing from 3 to infinity. All right, so at this point we can draw a possible graph of our function. So there's a graph that is negative and increasing in that interval, has a horizontal tangent and an x-intercept there, is positive and increasing on this interval, is positive and decreasing on this interval, and is negative and decreasing on this interval. That's the end of that example, and that's the end of the video. Thank you.